Hello and welcome to this week 6 TS session on constraint and unconstrained optimization. It's almost 3 p.m. I'll wait for people to join in so they can join in during the session. But I'll start solving some of the week 6 assignment problems to begin with. And then I'll be discussing the week 7 content and mostly similar to the assignment problems that you will find this week. So without further delay, I'll get started with the content of this week's class. The first thing that I would like to discuss today is the week 6 assignment solution. Okay. Next, I would like to discuss similar problems to assignment 7. Today I'll just probably wait for people to ask out. So yeah, doubt clearing if any, because there is not much to cover in this week's content because I felt the content was pretty easy. And I think you have already probably have solved assignment 7 itself. Let me start with this week's assignment solution. Okay, let me check what is the first problem. Okay, so the first problem is nothing but it's the transportation problem converted into an LPP. So let me write down this is a transportation problem. What you have here is that you have a bunch of origins and destinations. These are your these are your origins. D1 to DN, these are your destinations, and these are your costs. C11, this is C11, CN1, CN1, and yeah. Yeah, I'm writing down the entire thing, and then we have this AI PJs. So these you can write it as A1 to AN. So these are the just sums of those, and these are your column sums. Okay. Now the LPP version of this problem. So what you have here is that let's minimize z equals cx, and this is subjected to ax equals b, x greater than equals 0. So now the problem asks you the number of variables involved in the above LPP. So if you can notice, there's just the allocations that you have to make here, right? So find the number of variables involved in the LPP. Now let me solve this. So what you can notice here is that the variables that you have Xij for all I and for all j, right? So we can write Xij. I goes to from 1 to m, and j goes from n, right? So these are your allocations. So these are basically the allocations. So you have m times n number of variables, right? So therefore the number of variables so answer is right. So that's pretty easy. Next is number of equality constraints involved in the observability. So for this, we have for row subs, n constraints. For column subs, so these are equality constraints, right? N equality constraints. So your equality constraints. Okay. So what you have finally is that therefore you can write number of equality constraints involved in the LDB. So this is equals should be n plus n, right? So the answer is A. Okay, so the first two was pretty simple, related to transportation problem. Let's move on to the third one. So the third one gives you, so this is the transportation problem. So here what you have, let me write down the cost matrix. This is D1, D3 and D4, right? These are your AI, these are your PJ. So this is 19, 13, 15, 10, 17, 13, 14, 16, 14, 8, 17, 20, 7, 9, 18, 5, 8, 7, 14, right? Okay, so this is the transportation problem that's been given. The problem asks you find the cost of initial basic principle solution of the error transportation problem by one minimal method. Okay, so let me try to solve this. So let me first write down the entire thing again, and then I'll be solving this. Okay, let me. This is 19, 30, 50, 10, 17, 30, 40, 60, 40, 8, 70, 20, 7, 9, 18, 5, 8, 7, 14. This is origin 1, 2, and 3. This is destination 1, 2, 3, 4. This is your AI. This is your BJ. Okay, so what I can do, let me write down this the red markers, the allocations that I'll be making. So in that case, what will happen that in the row minimum method, first you'll be picking the cost that is minimum in the first row. So that's 10, right? So in that case, you will see if you can allocate the maximum one. So you can allocate this column corresponds to 14 and this row corresponds to 7. So this is anyway this entire row allocation that you can make exactly here itself. So you'll allocate 7 here. So this will become 0 and this will become 7. In the next step, what you can do, you can delete the first row itself and you work with the rest of the 2 rows. Okay, so in that case, just let me write down this again so that you are able to understand it from the note itself later. So I'll draw 2 rows. So this is O2 and O3. This is D1, D2, D3, D4. And I'm not writing down the cost anymore because that's visible from the initial table itself. Or let me, okay, write down for the sake of completeness. Anyway, I have time today. D8, 70, 20. So your AI is 9 and 18. Your BJ is 5, 8, 7 and 7. Now you will allocate again based on this row minimum method. Now what you can do, you have to again pick this one and check. So this is 30 is the minimum in this row, and you can see that from 8 and 9, 8 is the minimum. So the maximum that you can allocate here is 8. So this becomes 1, this becomes 0. Now you can also allocate the rest 1 in that row itself, and that you will do to 40 because that's the next minimum. So then this will become 6. So again you can delete the first row because now this has become 0. And you can work with the remaining row, which is the third one. Okay, so let me write down. So this is O3, this is D1, D2, D3, D4. This is 40, 8, 70, 20. This is 80. This is 5. In fact, I have to delete the second column again itself because you have already allocated the entire thing. So let me write down this modified one properly. So you can pick this as D1, D3 and D4. So this is 70, this is 20, this is 7, this is 7. Now you will do the allocations and you can check that it's pretty straightforward. First you will pick 20 and you can allocate 7 here. Then you will pick 40 and you can allocate, so this becomes 11. This you can delete. Then the rest of the 11, wait a minute, I think this should be 6, right? Okay, so this should be 6. Yeah, now this 40 is the next minimum one, and you can allocate 5 here, so this becomes 0. This becomes 6, and finally you can allocate 6 here. This becomes 0, this becomes 0. Okay, so let's calculate the cost of this initial basic feasible solution. So I'll write down here initial cost equals, first one had 7 times 10, then it had 8 times 30, then it had 1 times 40, then it's 5 times 40, then it's 6 times 70, and 7 times 20. So this is 70 plus 240 plus 40 plus 200 plus 420 plus 140. So ultimately what you have is 76, 18, 104, 11110, right? Yeah, so that's fine. And I think, which one is the correct answer here? Answer will be option C, right? Yeah, so that's all about the row minima method. So this is the row minima method. Let's solve the next problem now. Yeah, the fourth problem tells you find the initial BFS of the above transportation problem by column minima method. Okay, so let me write down the matrix, cost matrix again. Okay, so this was 19, this is 30, this is 50, this is 10, this is 70, 30, 40, 60, this is 40, 8, 70, 20, this is a 1, oh no, this is not O1, this one is O1, this is O2, this is O3, this is T1, this is T2, this is T3, and this is T4. This is AI, this is BJ, this is 7, 9, 18, 5, 8, 7, 14. So I didn't check one thing in the previous problem, it's that whether it's a balanced transportation problem or not. So let me quickly do that here. It will be, so this is 34, this sum, and here also it's 34. So this is a balanced So if it is not balanced, then you have to balance it using extra rows or columns. Okay. Now, what you can do, you can solve it using the column minima method. So let me do that. Okay. So in the first step itself, let's do the allocation. So, yeah, just quickly check. Yeah. So this is the column that you have to pick. So the first column, the minimum one is 19, and you have to pick the minimum of 5 and 7. So you can allocate 5 here. This becomes 0, this becomes 2, and you can delete the first column. So let me write down whatever is left. So this is D2, D3, D4. This is 30, 50, 10. This is 30, 40, 60. This is 8, 70, 20. This is 2, 9, 18. This is 8, 7, 14. Next, again you have to pick the next column, which is this one. And you can allocate 8 here, right? So 8 goes here. And this becomes 0. This becomes 10. And you can delete the first column. So I think you will understand the steps pretty easily. So and you have already solved this, but anyway, let's do this. So this is 50, 10, 40, 60, 70, 20. This is 7, 14. This is 2, 9, and 10. Now you have to pick the next column, which is this one. And here the minimum one is at 40, so we can allocate 7 here. So this becomes 0, this becomes 2, right? And as you can guess, you'll be left with only one column. So this is D4. So this is 10, 60, 20. This is 2, 2, 10. This is 14. And now the allocations will be, you can allocate 2 here. This becomes 0. This becomes 12. You can allocate 10 here. So this becomes 0. This becomes 2, and finally you can allocate 2 here. This becomes 0, this becomes 0. Okay, so now let me calculate the cost. Okay, so let me also write this is column minima method. Okay, so the first one, it's 5 times 19. Next you have 8 times 8. Then you have 7 times 40. Then you have 2 times 10 plus 2 times 60 plus 10 times 20. So what is left is 95 plus 64 plus 280 plus 20 plus 120 plus 200. So that's 300, 500, 620, 715, 779 will be the answer. Yeah, and I think option D is the correct one. Yeah. So answer is option D. Okay, so that's all about this fourth problem. So I think that was pretty straightforward as well. Now let me move on to the fifth problem, which is similar thing, but you have to solve it using northwest corner method. And you have a different transportation problem given. Okay, so let me write down this problem. So this is problem 5, and what you have here is that, so this is the given transportation problem. Okay, this is O1, O2, O3. This is D1, D2, D3, D4. This is AI, this is PJ. And let me now fill in the cost. This is 2, 6, 5, 9. This is 8, 3, 3, 2. And then you have 250, 350, 400. And here you have 200, 300, 350, and 150. First, let me check whether it's a balanced problem or not. So this add up to 1000, and this one also adding up to 1000. So this is a balanced transportation problem. Okay, now let me solve this. So the statement here is that find the cost of initial BFS by northwest corner method. Okay, so what I can do, I can write down this matrix again and start solving this. Okay. Okay, so I have written down this problem again, and now in the northwest corner method, what you will do is start to allocate from the northwest point, and then you'll move towards the east direction as much as you can, and then you will go to the south. Okay, so so this is the northwest corner point, right? So here you can allocate the maximum of or the minimum of 200 and 250. So you can allocate 200 here. So that's simple. So this becomes 0. This becomes 50. Now let me write down the updated matrix by deleting the first column. So this is D2, D3, D4. This is O1, O2, O3. This is 1, 7, 4, 6, 5, 9, 3, 3, 2. This is 50, 350, 400. And this is 300, 350, 150. Now again you start from the northwest point, right? So here again it's the minimum of 50 and 300 that you can allocate. So you'll allocate 50 here. So this becomes 0 and this becomes 250. Now you can delete the first row this time. So we're left with D2, D3, D4, O2, O3. Let me write down the cost. So this is 659,332. This is 350, 400. This is not, and this is will be 250, 350, and 150. Okay. So now what you can do, you can again allocate to the northwest corner. So that will be minimum of 250 and 350. So that's 250. So again this becomes 0, this becomes 100, and you can delete that column. So we're left with this D3, D4, and O2, O3. This is 5, 9, 3, 2. This is 100, 400, 350, 150. Again you can allocate to the northwest corner, and that would be minimum of this 2. So that's 100. This is 0. This is 250. So you're left with only one row. So this is D3, D4, this is O3, this is 3, this is 2, this is 400, this is 250 and 150, and as you can guess the allocations will be straightforward. So there, here it's 250 and you'll be left with only one cell, and so I'm directly writing 150 here. Okay, so that's how we do it. So we'll do everything in the northwest corner point. Okay, or maybe I'll just separately write it down so that you're able to understand that everything is happening here. Okay, so this becomes 150, this becomes 0, and now we're left with this D4, O3, this is 2, this is 150, 150, and now the allocation will be in the single cell. So now let me calculate the total cost. Okay, so let me write down. So this is northwest corner method. Yeah, first is 200 times 3, then it's 50 times 1, then it's 250 times 6, then it's 100 times 5, then it's 250 times 3, and finally what I had is 150 times 2. So let me calculate this. This is 600 plus 50 plus 1500. This is 500. This is 750. This is 300. And the sum will be 21526 3700. Yeah. So the answer will be option B. So answer is option B. So this is also fine. So that's the fifth problem. Now let me move on to the sixth problem. Yeah, so the sixth problem, it's saying to solve the same problem using matrix minima method. Find the cost of initial BFS. Just a minute. Yeah, of the above transportation problem by matrix minima method. Okay, so let me write down the matrix again. Okay, and this is your AI, this is your BJ, this is 250, this is 350, this is 400, this is 200, this is 300, this is 350, 150, 3174, 2659, 8332. Now in the matrix minima method, what you have to do, you have to find the minimum entry in this matrix. So here 1 is the minimum entry. So there you will allocate. So there you can allocate the minimum of 300 and 250. So 250 goes here and this becomes 0, this becomes 50 and you can delete the first row. So I can write down this is matrix minima method. Okay. Yeah, so let me delete the first row. So you're left with 26598332. This is O2, this is O3, D1, D2, D3, D4, AI. So this is 350, 400, and this becomes 250, 350, 150. Again, the minimum entry is 2 here, but it occurs at multiple places, but you can break ties randomly. So let me pick the northwest point here again. So this minimum of 200 and 350 you can allocate. So let me do that. This becomes 0, this becomes 150 and delete the first column. You're left with 659,332, 150, 400. This is 50, 350, 150. And the minimum occurs at this one where there is another 2. And you can allocate 150 there. This becomes 0. This becomes 250. And you can delete the last column. So you're left with D3, D4, and O2. It's not D3, D4 actually, it's D2, D3, O2, O3, 6, 5, 3, 3. This is 150, 250. This is 50, and this is 350. So again, you can break ties randomly, and let me pick the leftmost 3 and allocate there to begin with. So 50 goes here. Okay. Now this becomes 0. This becomes 200, and you are left with only one column. O2, O3. This is 150, 200. This is 350. And as you can guess, the allocations will be straightforward. Here it will be 200. So this becomes 0. And finally, we're left with only one cell. So we can allocate 150. So this becomes 0. This becomes 0. Okay, so let me now calculate the total initial cost. Yeah. So it's 250 times 1, then you have 200 times 2, then you have 150 times 2, then you have 50 times 3, then you have 150 times 5, and finally you have 200 times 3. So you have 250 plus 400 plus 300 plus 150 plus 750 plus 600. So I think the sum will be 2450 if I'm not wrong. Yeah. And that will be option C. Yeah. So option C is the correct answer here. So that's all about the sixth problem. Now I have the seventh problem, which tells me to do this in Vogel's approximation methods. I'll do that. I'll have some water and start doing it. Okay. So actually I noticed in this Vogel's approximation method that you can do it, this tie breaking thing, you can do it in multiple ways and you probably get to different solutions in that case. So you have to be like, I don't know, these options are given, but sometimes you may end up which is not in the option. But yeah, but I think you'll reach one of the options by taking the tie breaking criteria like randomly, and probably in one of the cases you can get to the solution. But anyway, I don't think anyone will be facing much issues with that, so I'll be solving this method so that I get a solution which is there in the options. Okay. Okay, so let me write down the seventh problem. Okay. Find the okay, so I think the transportation problem is different here. Okay, let me write down. So the given transportation problem, so what you have here is AI, this is BJ. This is 80, 100, 85, 90. This is 95, 85, 80, 100. And then you have 90, 80, 95, 90. This is 1500. This is 1500. This is 1500. This is 1000, 1300. This is 1200, 1000. Let me first check whether it's a balanced problem or not. So this is also same. So this is indeed a balanced transportation problem. Okay, so that's good news. Now, what you can do, you have to find the cost of initial basic feasible solution of the above transportation problem by VM method. So that's Porgel's approximation method, right? Okay, so in this, let me start solving this. So what is typically done in Vogel's approximation method is that you can take the difference, I think, between the the least element and the second least. I think that's one way. I'm just checking that's correct. Okay. Yeah, so what you have to do yeah, so let me write down the problem again. This is a 1O2 O3. This is D1, D2, D3, D4. AI, BJ. This is 80, 100, 85, 90. This is 95, 85, 80, 100, 90, 80, 95, 90. This is 1500, 1500, 1500. This is 1000, 1300, 1200, and 1000. And now what you can do is you can take the difference between the least cost and the second least cost of every row and every column. So here the difference is 85 minus 80, which is 5. Here it's 85 minus 80, which is again 5. Here it's 80, so 90 minus 80, which is 10. Here it is 90 minus 80, which is 10. Here it is 5. This is 5. This is 10. Now, you have to pick whichever is the maximum one. But you can notice that maximum is 10 and it occurs at multiple places. So first what you can do, you can pick this column, suppose. So that's why I told that this tie breaking thing might play a role and you get a different solution, but that's fine. And out of this column, whichever is having the least cost, which is 80, and you see how much you can allocate there. So you can allocate 1000 here. So this becomes 0, this becomes 500, right? And you will delete that column and you will repeat this process again. So let me do that. Okay, so this is now D2, D3, D4. This is O1, O2, O3. This 100, 85, 90. This is 85, 80, 100. This is 80, 95, 90. This is 500, 1500, 1500. Then you have 1300, 1200, 1000. Okay, so we'll repeat this process again, and in the first row now the difference is again 5. Second row it's the difference of 5. Third is 10. Here the column wise differences will be same. Yeah, because you have deleted the first column. Now again it occurs at two places. There's 10 value, and you can again pick, suppose the last, you can do it column wise. So you can pick this column, and now you can notice that what you can do. So this you can pick this 90, and then that occurs at two places, but let me take the one which kind of gives me maximum allocation. So here you can allocate the entire 1000, but if you had picked this one, you probably would have done 500 only. So now that's good news, and this column can be deleted. Okay, so let me write down the next step. So this is D3, this is D4, this is O1, O2, O3, this is 85, 90, 80, 100, this is 95, 90. Just a minute, let me check. My internet is working. Okay. Yeah, so it's working properly, I think. Now, let me write down the remaining allocation. So this will be 500, 1500, 500. This is 1300, this is 1200, and whatever you are left with. So this is again you have to calculate. So this becomes 15 now. This becomes, if I'm not wrong, okay, I made a mistake because D4 will be deleted. So D2 and D3 should be there, right? So this is D2 and this is D3. So 85, so this will be changed, not this one. Yeah, so this will be 100, 85, 80, 85, 80, and 95. Yeah, first one will remain as 15. Next one will be 5. Third one will be 15. This one, column wise, this will be 5. This will be 5, right? So 15 is again the maximum, and you can again pick one randomly. So let me pick this row. and the minimum one here is 85, and you can allocate 500 there, right? Yeah, I could have picked the other one as well, but in that case you would have allocated uh, yeah, 500 in other places, but that's fine. Let me do that. Okay, so 500 goes here, so this becomes 0, this becomes 700. Okay, now let me move on to the next step, which is you will delete the row, so you're left with O2 and O3. So this is 85, 80, 80, 95, 1500, 500, 1300, 700. You again will repeat this exercise, and this one is 5, this is 15, this is 5, this is 15, and you can pick again one of them randomly. Let me pick this row again, and 80 will come here and 500 can be allocated here. Okay, so this becomes 0 and this becomes 800. So you are left with only one row. So this is T2, T3. This is O2. Yeah, it's straightforward. You need not calculate anything, but I'll just still write 5. But this is step. So what goes here is that just a minute, I think I made one mistake somewhere. Okay, so I think what I made a mistake is this in tie breaking. So let me do this again. So after the first step, I think things will be changed a bit. Yeah, the first step was fine. After that, I think I picked the column, but let me pick the row there. Okay. So let me erase this everything. Okay, here let me pick this row instead of that column, because ultimately I need to get an answer which is there in the options. Now in this row the minimum one is 80, so you can allocate 1300 there. So this becomes 0, this becomes 200, and you can delete that first column, right? Yeah, so let me erase the rest of the part so that there is no confusion. Yeah, that's the problem with this Vogel's approximation method, and whenever you have a solution based on options given in the MCQ. Now let me delete that one and start doing it again. Okay, so what you have right now is this one. In fact, even before I delete that row, I have to allocate 200 here because the next minimum ones is 90. So this will be the updated one. Okay, so the last row and the first column both can be deleted, and you are left with okay, something like this. So this is D3, this is D4, this is O1, this is O2. So this problem is kind of tricky because of, as I mentioned, of the options. So this is 500, 1500, this is 1200 and 800. Okay, so now let me follow the same step. So this is 5, this is 20, this is 5, this is 10. Now there is no confusion. This one you'll be picking. 8 is the minimum, so 12. Okay, so 1200 goes here. So you're left with 300. This is 0. 300 must be allocated here. Okay, so this becomes 0. And finally, what you have is only one cell, that's 90. So 500 will be allocated here. And this becomes 0. So first this will become 500, then 0. Okay, so I've shown some steps together here. So now, so this is VAM method. Total initial cost this is 1000 times 80 plus 1300 times 80 plus 200 times 90. Then you have 1200 times 80 plus 300 times 1000. Oh, not 1000, it's 100 plus 500 times 90. So you're left with 80,000. Okay, let me directly calculate this. So this will be okay, so it will be 373,000, like, yeah, so this will be the answer. So if I had taken the other route of tie breaking, so the answer would have been different, and it won't end up anywhere in the options. Okay, so here the answer to this problem is A. Okay, so just be careful with this method, and yeah, please follow the steps that I have done carefully later on. Okay, so let me now solve for the optimal solution of this problem, and that you have to do by UV method. Okay, so let me quickly do that. Okay, so the next problem is find the cost of the optimal solution of the above transportation problem by UV method. Okay, so let me quickly draw the table again. Oh, okay, just so this is O1, O2, O3. D1, D2, D3, D4. This is AI, this is BJ. And what you have is this cost. So this is 80, 100, 85, 90, 95, 85, 80, 100, 90, 80, 95, 90, and this is 1500, this is 1500, this is also 1500, this is 1000, this is 1300, this is 1200, and this is 1000. Now let me also write down the allocations, the final allocations that you have got. The allocations are 1000 here. Next is at O3 D2 is 1300. Then it's 200 at O3 D4. Okay. Next is at O1 D4, so that's 500. Then it's O2 D3, 1200. This is 300, right? So let me just check the sums quickly. So that's fine. Okay, so these are my initial allocation, not the optimal one. So now what I can do, you have to first pick the highest occupancy column, or you need not do that. So the occupancy cells, or the occupied cells, here are 1 1, 1 4, 3, 2 3. The row comes first and then the column. 2 4, 3 2, 3 4. So it doesn't create any cycle as such that you can notice through the occupied cells. And number of occupied cells, here is 6, which is equals to m plus n minus 1, which is m is 3, and this is 4 minus 1, which is 6, right? So this is true, so that's valid. And now you have to in UV method, so let me write down this UV method. Yeah, so for occupied cells, what you have is the following equations, which is, say, U1 plus V1 equals C11, which is 80. Similarly, U1 plus V4, which is equals to 90. Then, or I can write it as, first let me write down, yeah, C14, which is 90. Then it's U2 plus V3 equals C23, which is 80. U2 plus V4, which is C24, which is 100. Then it's U3 plus V2 is equals to C32, which is nothing but 80. And finally, it's U3 plus V4 is equals to C34, which is 90. Okay, so that's fine. Now the highest occupancy cell is this one. So this is the highest occupancy column, not the cell. So that means set V4 equals 0 and you will get the rest of the values. So V4 equals 0 gives you 3 equals 90. Then that gives you V2 equals minus 10. Then it gives you U2 equals 100. Then that gives you V3 equals minus 20. Then it gives you U1 equals 90. That gives you V1 equals minus 10. And you already have V4 equals 0, right? Okay, so that's the 7 values that you have got. And yeah, so this is the solution. That's one solution that making this V4 equals 0. Now what you can do, you can check, or rather let's pick one thing. Let's do one thing. Yeah, for unoccupied cells, you have to check this. Next is for unoccupied cells, check delta Ij, which is Cij minus Ui plus Vj. Now let me check that. So delta 1 2, delta 1 3. Delta 1 2 is let me directly write it. So this 100 minus U1 is 90 and V3, so that's 70. Sorry, delta 1 2, so that's 90 minus 10, 100. So that's 100 minus 80, which is 20. Similarly, if you calculate, we'll get delta 1 3 as 15, delta 2 1 as 5, delta 2 2 is minus 5, delta 3 1 is 10, and delta 3 3 is 25. So only this one is less than 0. So you have to increase, or you have to enter something in that column, right? It's that 2 2 cell. So that the thing that you can enter there is the minimum of whatever is appearing in that cell. So that's 300 and 1300, right? So that's the minimum of those two. So it's minimum of 1300 and 300. So that's 300, and 300 amount you can shift to that row, right? Then you can construct a cycle like this. So if you're increasing 300 there, so you can decrease 300 from here. That means you have to increase something here, then you have to decrease something here, again come back to this. Okay, so your allocations now will be slightly different. So this is your new allocations. So this is 1000, this is 500, this will remain as 1200, the rest will change. So actually here will be include this plus 300, so that will become 300, the other one will become 0, so this becomes 0, then the bottom one will be 500, and with that this will be 1000, and yeah, now everything is again balanced. So what you have to do, you have to calculate this UI and VJs for the occupied cells again, right? So again, what you can do, let me do that. So for occupied cells, so it's again E1 plus V1 equals 80, U1 plus V4 equals 90, U2 plus V2 is the new thing that have been introduced, and that cost was C22, which is 85. Then you have U2 plus V3, which is 80. Then you have U3 plus V2, which is 80. Then you have U3 plus V4, which is 90, right? So let me pick which one is the highest occupancy cell. So this one you can again pick as 0. So let's set V4 equals 0. So that will give you U3 equals 90, V2 equals minus 10. Then what you can get is U1 equals 90, V1 equals minus 10. Next is how to get this. Yeah, V2 is minus 10. Yeah, U2 is 95. V3 is minus 15. Yeah. So it's 90, 90, 95. And this one is minus 10, minus 10, minus 15, 0. Okay. So this is fine. Now let's calculate this. Delta Ij for non-occupied or unoccupied cells, right? For unoccupied cells, so it's delta 1, 2 will be 80. Oh, sorry, it's not 80, it's 100 minus 80, so that's 20. Yeah, similarly, if you calculate all these deltas, so this delta 1, 3 will be 10, delta 2, 1 will be 10, delta 2, 4 will be 5, delta 3, 1 will be 10, delta 3, 3 is 20. And this all of this are greater than equals 0, so this is optimal allocation. Now you can calculate the optimal cost. So let me do that. So optimal cost will be, we'll quickly see what was the cost matrix like. So that's 1000 and 500, okay. 80 times 1000, 90 times 500. Next is 300 and 1200, okay. So that's 85 into 300, 80 times 1200. And finally what you have is 1000 and 500, so that's 80 times 1000 plus 90 times 500. So if you do that, this will be 80,045. So that's okay. Let me calculate this. Okay, so it will be 371,500. Okay, so yeah, so this will be your optimal cost, and let me check uh, which one was the. Okay, okay, so let's do this. So the answer will be D, right? Okay, so that's all about Vogel's approximation method, and yeah, it was a little bit tedious job to do it, but that's fine. Okay, so let me do this problem 9 and 10. Problem 9 is find the optimal assignment of the following job scheduling problem. Okay, find the optimal assignment of the job scheduling oh just okay, so this is in fact we have this, so this is J1, J2, J3, J4. So every job must be allocated to only one worker. This will be W5, and so that the cost is minimized. So it's a transportation problem with row and column sums to be 1. This is 10, 7, 2, 2, 2, 7, 11, 9, 7, 12. Okay, so yeah, I have another J5. What's this? So that's 7, 9, 10, 4, 12. Yeah, now it's fine. So the number of assignments, okay, you will do later. Okay, so now let me start this problem. Okay, so yeah, what you first can do, let's do the first transformed matrix. So first you will take the rows, and the minimum at every row you will subtract uh, from every element of that row, right? So this will be, next it will be 3 will be subtracted, 15, 13, 3, then it will be 2 which is be subtracted, 8, 5, 0, 0, 0, then 7 will be subtracted, so that's 0, 4, 2, 0, 5, finally 4 will be subtracted, so that's 3, 5, 6, 0, 8, and every column, then you pick the column and then subtract. The minimum one at every column is 0 anyways, so the same thing you will get back also. Now you will start to allocate. by the row. So for suppose you allocate to this row and just box this. Next one, you can also allocate in this, but then you have to cross out the corresponding columns, right? This one. And the third one, you cannot do anything because there are multiple zeros present. Fourth one, you can again allocate because you have already crossed out one. And now you have to cross out everything that's there in that column. And then you are left with, I think, okay, so you can now start to do it in the column wise fashion. So once you do this, you can pick this one again and this will be crossed out. Okay, but now the number of assignments is equals 4, which is less than 5. So this is obviously not the optimal one. So what you can do, you can from the occupied rows, you can draw straight lines, and from the unoccupied column, you can draw straight lines. So suppose this you can draw, this also you can draw, this is something you can draw, this one is also allowed, and finally what you have is the unoccupied one, which is or yeah, just a minute. Okay, yeah, let me erase that. So what you can do through the crossed mark, so let me do this. Okay, where it's I made one mistake. Yeah, just check and solve this. Just a minute. Um, okay, so uh, what you can do, yeah, the row that is not occupied. So this one you can put a tick here, and corresponding to that, wherever zero is occurring, so you can put a tick there, right? Now through this ticked portions in the column, so you can draw a straight line, and from the other unticked portion of the rows, you can draw straight lines, right? So now let me do that. So whatever is left out is, and except for this intersecting points, is okay. So in fact, I think let's solve it in a different fashion. Okay, so here, so this is the ticked row. Then this is the ticked column. And once you do that, kind of delete everything from that. So this will be again a ticked row. And once you do that, what happens is that the next one is not a ticked row. Yeah, so again you will just corresponding to this, zero occurring is here, so you'll tick this column, and due to this column again there is no zeros here, so this is a ticked row. Okay, so this will be the correct ticked rows, and then what you can do, you can draw vertical lines through the ticked columns and horizontal lines through unticked rows. Yeah, whichever is not covered here, so out of those, the minimum element, minimum uncovered element is 2. So that's fine. Now, what you can do is simply uh, do one thing, which is uncovered elements -2 and intersecting elements +1. Sorry, +2, whichever is this minimum uncovered thing. Okay, so the transformed one, so that will be 5. So that will be an intersecting point, so that will be increased to 7. This is 0, 8, then 10 will be increased to 12. This is 11. Then what you have is 0, sorry, 0. Then these are not covered, so that's 4, 13. Then this will be this will remain as, I think, 13, if I'm not mistaken. Okay, yeah. So after that, the next one will be uncovered, so that will be 1. Yeah, next is this is an intersecting one, so that will be increased to 10. Then this will remain as 5. This will remain as 0. Then this is another intersecting one, so that will be increased to 2. Finally, you have another one which is 0. Then you have this as 0, unoccupied one, so this will be 2, this will be 0, this will be 0, this will be 3. Then you have 3, 3, 4, 0, and this will be 6. Okay, so now let's try and do the same thing again. So in the first row, so you can pick this one, so that's fine. In the second row, there is only one, so this one is also that you can pick. This one crosses out. The third one, you cannot do anything right now. Fourth one, you cannot do anything right now. Yeah, fifth one, again you can pick this one. And you can cross this one. Now column wise, you have to choose. So the first two, the last column, you have to pick this one. And you can cross out this one. And here you can just pick this one. So that's fine, right? So what happens is that J1 to W2, J2 to W1, J3 to W5, J4 to W3, so, and J5 to W4. So this is the answer, and this answer will be option D, I guess. So yeah, so that's the correct answer. Now let me go into the last problem, which is problem 10. So find the optimal assignment of the following job scheduling problem. And let me write down. So it's the similar problem. Okay, so let me write this down. So, so this is 8, 26, 17, 11, 13. So that one you cannot allocate, so you can put a very high cost to it. Okay. So now, same thing you will do. So the first row, you can just have it as 0 because 8 is the minimum one. Okay. Next one, 4 is the minimum one. Yeah, next one, 15 is the minimum one. And the last one, 10 is the minimum one. Then column wise you can also do. So that will be first one, the column wise will be the same. Second one, 4 is the minimum one. Third one will be same. Fourth one will be same. Now you'll try to allocate this again. So the first one you can pick this one. Nothing else is appearing here. Second one is you can pick this one, so that's fine. Last one you can pick this one. You can cross out this one. Column wise you can come and pick this one. Okay. So the allocations is pretty simple. J1 to W1, J2 to W3, J3 to W2, and J4 to W4. So the answer will be option A here. So this answer is option A. Let me just quickly check the previous one. Okay, so that's all about the solution of assignment 6. Now let's quickly go through the problems related to assignment 6. Okay, let me see what is there in assignment 7. Okay, assignment 7. Okay, let me quickly download this. And, okay, let me just check how much time left. Okay, around 15 minutes I have. Yeah, the first problem is I think you are given a function and you have to tell whether it's a polynomial or polynomial, those kind of things. So you should know the definitions of polynomial and this polynomial thing. And after that, I think you can answer it easily. So it's the topics, I'll write it down. Probably next week I'll explain all those things. So that's first problem. Okay, for some reason it's not downloading. Anyway, so let me solve similar to second problem. So what you have is say x1, x2 is 7 plus 3x1 plus 2x2 plus say 4x2 square. Sorry, okay, 4x2 square plus 3x1 square minus 2x1 x2. And suppose you are given something like this. So what you can do here is that you have to find the C and this Q, small q, capital Q, and other things. So what you can do, and write it as C plus Q1, Q2. This is x1, x2. This is half x1, x2. This you can write it Q1, Q2, Q3, Q4. This. And then what you can do, you can just simplify this or multiply everything, and then just you will get bunch of equations and you can get the solutions. Okay, so that's probably two. Then let me check the third problem. Okay, so the third problem says uh, about local maxima and local minima. Suppose a function like this is given, say x cubed plus 4x squared. So that's just a minute. Okay, sorry, x minus 8. Okay, suppose this is given. So now what you can do, you can get f prime x, which is 3x squared minus 8x plus 8, and you can equate it to 0, and you can get something like 24. So that's just a minute. Let me make this as 4. So this is 4. Now it's 6x minus 2x plus 4. So you'll have 3x minus x minus say 2 minus 2 x minus 2 equals 0. So from here you will get x minus 2, 3x minus 2 equals 0. So x is either 2 or 2 by 3. Okay, so now you can check for the second derivative. So this is f double prime x. So that's 6x minus 8. So f double prime 2 is 4, which is greater than 0. F double prime 2 by 3, which is 6 times 2 by 3 minus 8. So that's minus 4. I'm not wrong. That's less than 0. So this is local minimum. This is local maximum. Yeah, so these are the basic problems that you might find. Okay, so I'm not going into the exact uh, numbers that you have to do. So again, fourth problem is similar. Local minima, local maximum type of problem. Fifth problem is something which is about point of inflections and those things are there. So it might happen that so f double prime x equals 0. So that could be a point of inflection. So let me take a function. So say if x equals x cubed. So f double prime x is 3x squared. So this is say 0. So that gives you x equals 0. F double prime x is 6x. So this is also 0. F triple prime x is say 6 and that's greater than 0. So here, since this is true, so x equals to 0 is a point of inflection. So that you have to keep in mind while solving this fifth problem. Yeah, sixth one is again similar. You have to find the point of inflections. So that's similar to 5. And then you have the seventh problem, which is about solving this by graphical method. So I'm not, I think I won't be going into the details of this in today's class. In the next one, I'll discuss this. Yeah, so you can always do it graphically and solve it since it's a direct question kind of a thing. Stationary points definition you already know that uh, you have to suppose I have given you a function. So 7 so will be discussed next week. Yeah, eighth problem is something which is interesting. So the stationary point is again the solution point that you can determine. So, oh, that's in problem 9. So this is same. Ninth is about the stationary point. So suppose the fxy is given as x squared minus 2x plus 3y plus y square. So now you can do this grad of fxy. So first you'll be taking the partial derivative with respect to x and then the partial derivative with respect to y and set this to 0. That so you'll be getting x equals 1 and 2y equals minus 3. So that means y equals minus 3 by 2. So the stationary point is nothing but x star y star equals 1 comma minus 3 by 2 here. Okay, so that's fine. And the 10th problem is again about the saddle point. Saddle point is again similar to the point of inflection and local and global maximum, so those things. So 10th problem is similar. So I think assignment 7 is pretty straightforward and I think I'll be able to solve it and I'll discuss it next week. So yeah, so that's all about what I wanted to discuss this week. And yeah, the assignment 6 was a bit lengthy and a bit tricky to solve. And yeah, I got that I have solved everything. And yep, so that's halfway of this course. So search part is done. Now only ma'am's part is remaining in the next 6 weeks. And yep, so I think this part will be a bit easier or sometimes it may require solving something graphically or numerically those things. I'll probably take help of some solvers in the next week. I won't be doing everything probably by hand. And yep, so and from next week probably what will happen is that since this assignment is very short, so I'll probably be done with discussing this within half an hour or so. So I'll wait for people to ask questions. If anyone has, they can join. Otherwise, I'll just wait for that duration. I won't be discussing anything new because anyway, that's not the scope of this course and this TA sessions. So yeah, I'll just be there during this TA session and we'll wait and post the recording later in YouTube. Okay. So yeah, with that I'll stop. But since it's okay, around 5 minutes, I'll wait, and if anyone joins and asks questions, they might do that. But otherwise, I'll close the session in 5 minutes time. Okay, so I think it's almost time. Yeah, so yeah, close the session for this week. Hope someone joins next week because it won't be a long discussion next week anyway regarding assignments. So if you have doubts, do join and ask questions. Otherwise, I'll just wait for like the duration of this class and yeah, we'll post the recording if any in YouTube. Okay, so see you next week.